All right, so here is a quick video kind of going over what we just talked about. So in here, we have the total nitrogen for Idaho and our lakes. So I just kind of like to zoom in just so I can have a lake and a reference point in case I want to kind of click back and forth to see what I'm doing. So the first thing we need to do is, as we talked about, this layer is a raster. It doesn't have an attribute table because it is a 32-bit floating point, and you can't make a value attribute table or attribute table that has decimal points. So the first thing we want to do is geoprocessing is we want to go into the raster calculator. So if we just type in raster calculator, there's two. There's one for images and there's one for spatial analyst tools. We want to use the spatial analyst. So just open that up. So the first thing we want to do is we had our decimal points. So we talked about 7, 1, 2, 3, 4, 5, 6, 7. Maybe we could use 8. I don't know, we'll give it a try. So what we want to do is we want to find this layer, which was total nitrogen Idaho. Next thing we want to do is go over here to operator tools, use the multiply, and then we'll type in maybe 8. 1, 2, 3, 4, 5, 6, 7, 8. I don't know if that's enough. Next thing, make sure where this is kind of going. I'm going to call this Idaho, and then 8 times for me, just so I know that I multiplied it by that value. Then I run it. And so now I have this that's just creating these values. So if we kind of look here, so let's take a look. So if we click on this little point here, we have 32, 86, 25, 32, 86, 24. So there's too many decimal points there. It's just going out too far. So we have to cut that back because it was 36, 32, 86, should be 25. We got 78 there. I guess if it rounded up, that 4. But that's the process. So you have to kind of figure out which way to do. But for this purpose, it's fine. So you notice though that it still has a decimal point. So that means if we open this up, there's not an attribute table because it's 32-point floating. So now we need to make this into an integer. And we can then go in here to the raster calculator again and just highlight this, delete that. So what we want to do is go to the operators, and we want to convert this new layer that we made, raster, into an integer. So find the int, and just leave this as it is, and then here it is, the 8 times, which was too many. Put it there, and now it's going to create an integer with a value attribute table. So you can just put something like maybe at the end. You can name it whatever you want, but I just kept this Idaho that I know I multiplied it by 8 times, and then it's going to have a value attribute table associated with it. So then I click run, turn these off, and now we notice the VAT. Maybe that's a better value here. Let's see, turn that off to 2478. Oop. So yeah, still so many decimals. But anyways, we got the right idea. We got the table. So we scroll out. We can kind of look and see what we have. Open up this attribute table. Now we have an attribute table. Object ID, GIS just assigns an object ID to every single row. Has a little star there. That means you can't edit it. The value is the total nitrogen levels. Just multiply that by 1,000. Count is how many times this value is associated with a cell. So we have that. But it is still in a raster format. Now what we want to do is we want to make this into a polygon so we can clip it. So if we go back to the geoprocessing, we can go to raster to poly. So raster to polygon. So the input raster is only going to give us this one because it's the only one that has a value attribute table. Field is going to be the values that we want to stay, and then we can give it a name. Get rid of that and just call it this. CG Idaho Poly, I guess. I don't know. Give it a name and leave the rest of that, and then we can run it. So now we have this value. It's just my pop-up's not formatted correctly, so it's just giving me probably the value attribute. It's probably giving me some object ID. But if we go up here, has an attribute table, grid code. Remember, if we're doing all before we do all these calculations, we're going to want to project our data because it could affect our area, especially as you get to bigger and bigger geographic areas. But in any case, we have that. If we go here to Symbology, and we go to graduated color, grid code, and there we have our values. So now what we want to do is here's our lakes. So now we would like to clip these lakes, clip the nitrogen data so it's only within the lakes. You can do that for HUCs too. So here we would go and type in clip, and we want to use the analyst tool clip. So here, the feature to be clipped, which is the nitrogen, because that's what we want to clip. The clipping feature, this is going to be what is the vector data that you're going to use to clip, and then this is going to be the lakes. And so then we can give it a name. Lakes, I guess, I don't know, whatever is right. Run. Turn that off. So now I'm gonna add, you can go to Symbology, grid code. So now we have those values. I just need to and so now we have our values for those. Again, they're multiplied by 8. It's going to be probably too big of a value. So do that. We can see now the nitrogen in this part of the lake, in that part of the lake. We go back to our original values here. And we kind of going to give me the lake. Turn that off. Oh, I just got the different pop-ups. I have to reconfigure my pop-ups to do that. I'm on the wrong thing. But yeah. Get out of that thing. So without reconfiguring my pop-ups so they show everything, we still got this. Turn that off. Lakes, where's another layer? It's on here. Idaho. So that's that. So then we can open up the attribute table. What we have to do here is figure out there's 115 polygons that comprise these various lakes, and the things that we want to kind of, how can we aggregate or join these kind of things, and there's various ways of either exporting it out, but then you'll be able to calculate the total nitrogen for those lakes. So if you have any other questions, email me, and can help out.